when we are assigning a value, we're first evaluating the right-hand side of the equation, right over here. This time around, the node.next is still free. And then we are assigning node.next to this new linked list, which is going to be with a 5 with the next value of 3. Hope that makes sense. Okay, then we are going to return our node.next, and we can just bang it out with a bang operator because we do know that it's going to be available. Let's do the defer. I'm not going to talk much about the defer right over here. Go ahead and check out the previous episode so you better understand what it does. And finally, what we need to address is one tricky situation. What if our node that we want to insert our value after is actually the last one, the tail? Well, that's actually how we are going to append. So we want to guard against that. Guard, it's not the tail, else we're going to do something else. Otherwise, just go forward. And we are going to append. So the append functionality also has a returning a linked list node. So we are just going to return append and then value. Simple as that. Okay, so you do want to make sure that, oh, it's not tail, sorry, node. We are checking against tail and node. So the tail should not be the node that we are inserting after. If it is, it's just a simple append. Great. Now it's time to make this even simpler because, you know, this would be a two-step operation. First, we need to find a node and then we want to insert it. It would be really nice if we just had an insert value at index, not after node, and then we just want to node at index. Let's kind of make these two functionalities into one. It's still going to be a discardable result and a public mutating func insert value of type value, and now at index of type int, and it's still going to return us a linked list node. But because our node at is returning, which we are going to use, returning an optional linked list node, we are going to need to return right over here also an optional linked list node with a value. Okay,